So this is going to be the calculus way of defining vertical asymptotes, because infinite limits title says that the answer should be either positive or negative infinity. So we are going to look into the limit as x approaches some value a, let's say from the left first, of f of x, and the answer is either positive or negative infinity. And then limit x approaches a from the right, which is a plus, of f of x could also be positive or negative infinity. If we get any of these to appear, we know that there is a vertical asymptote at a. So I will just write now with red, if any of these is true, we have vertical asymptote at x equals a. So this is your definition for vertical asymptotes now. And you will be computing these values to find vertical asymptotes in the future. I will give few examples, and we're done, believe it or not. So we start with 1 over x. That's the standard first example. So you have limit x goes to 0 for 1 over x. Well, we know that the limit doesn't exist there, because if you look at the graph, you see that the left and the right limits do not agree. So we know that the limit does not exist. But that doesn't violate our definition for vertical asymptote, because for vertical asymptotes, you are supposed to check one-sided limits, not the overall limit at 0. So if you look at the one-sided limits, you have that the limit as x approaches 0 minus, which means from the left, of 1 over x is equal to negative infinity. So that's this red approach from the left, and you see that the answer goes downwards. The y value tends to negative infinity. So left approach gives us negative infinity, and that is already enough for us to claim that there is a vertical asymptote at x equals 0. So this is enough for us to claim that vertical asymptote is at x equals 0. That was enough. But you know what? Let's do the right approach as well. So limit x goes to 0 plus of 1 over x is positive infinity, which is also enough for us to claim that there is vertical asymptote at x equals 0. There is no need to do both. One is sufficient when you have it like this. So this minus and plus, we discussed that last time. So minus means approach from the left, which is generally what I go with the red approach. And then the 0 plus is the blue, which is positive infinity in this case. So this was an example of how to find the infinite limit. And if you just think about the title for about 7 seconds, you immediately realize that the answer is infinity on one of the one-sided limits. So next example would be if this is a shifted function. Now, we also have to think a little bit. So let's take a look at, say, 5 over x plus 1. Plus 3. So it's a little bit away from. And what should I approach? Well, let's approach 0, because let's do that first. Let's approach 0. So what's the limit? It's 5/3. You see, nothing weird is happening when you have x approaches 0. 0 plus 3 is 3, so answer is 5/3. So you are technically talking about the y-intercept at 5/3 because x0, right? It's on the y-axis, x equals 0. Now I'm going to take the same example, same function, but I'm going to approach -3. What's going to happen now? Now we're going to have a vertical asymptote, yes. But see, you cannot approach -3 in general. You cannot approach -3 from both sides simultaneously. You have to do left one, separate from the right one, and see what the answers are. If any of those are infinity or negative infinity, we have a vertical asymptote there. Limit x goes to -3 from the left, so minus, -3 minus, and then we have 5 over x plus 3. So what is this limit? Well, luckily you know how to graph because you took Precalculus course, otherwise this would be just terrible. You know that plus 3 on x means shift everything to the left 3 units. Awesome. So as we are approaching -3 from the left, what are we getting? Negative infinity. Thank you, friends. And then we have limit x -3 plus 5 over x plus 3. And that one will give us what? Positive infinity. And we have, so either one of these or both say vertical asymptote at x equals -3. Please make sure that you are not writing VA equals -3 because that, remember the OCD part, right? That has no meaning in mathematics, VA equals -3. Equations for horizontal and vertical asymptotes are either x equals a number or y equals a number. So make sure you are writing it correct. So that is our vertical asymptote. X equals to -3. Cool. So now let's take a look at a spicier example. Let's say you are considering a function x minus 5, x squared minus 25. And you would like to know, are there any vertical asymptotes? And if there are, where are they? -5, I heard 5, yes? -5? -5? Plus or -5, yes? No vertical asymptote. So we have all possible cases. I heard only 5, only -5, both -5 and +5, and no asymptotes. So we exhausted all possibilities, right? Well, it's math, so only one of the 3 is correct, right? We have to figure out which one, and we're going to use calculus to do that, obviously. Now, I will just say one thing. We are very careful in pre-calculus not to ask a question like this because, you know, the methods we learn there are incomplete. Yes? X equals half. That's a new one. Okay, so now we have added one more. Half. All right. So let's do it. The way you did these problems in your pre-calculus course was to set denominator equal to 0, and whatever it spits out as numbers, that would be your vertical asymptotes, and you're done. I hope you all remember that. Well, now in calculus, this is how we start the problem. But the numbers that we get are candidates, not necessarily asymptotes. So now, when I set x squared minus 25 to 0, I'm going to get x equals to plus minus 5, and I don't get to claim they're vertical asymptotes. I get to say these are the candidates to be vertical asymptotes. And now, once I have the candidates, I'm going to unleash the calculus definition for vertical asymptotes using the limit and check. If I get infinities, we're good to go. If I don't get infinity, it's not an asymptote. So we start with whatever. You want to start with positive or negative 5, doesn't matter. Negative 5, okay. And we know that we have to do one-sided, so you pick either from left or right, it doesn't really matter. We have x minus 5 over x squared minus 25. Now we try to plug in. We always try to plug in. And we see that we get over 0. So if it's over 0, that's an issue. So what we do is we have to figure out from 2.3, from last section, which method is appropriate. And method that is appropriate is factoring and then canceling. Very good. So copy the limit. And then factor the denominator, x minus 5, x plus 5. These guys cancel. Write the limit one more time. So we are supposed to solve this limit now. Well, the way to do it is we can graph this because it's easy, right? Otherwise you do the chart, it takes forever. So we graph this one. Because we're clearly getting 0 in the denominator, we can't plug in, right? This one is shifted 5 units to the left. That's negative 5. And we have our 1 over x graph going like that. So now we have, if we're going from the left, which is the red approach, what's the answer? Thank you. Negative infinity. Now, guys, this is enough. We don't have to do the approach from the right. This is good enough. We found that the limit, as the approach from the left, we found that the limit is one of the infinities, in this case, negative infinity. So this was good enough for us to say that there is a vertical asymptote at x equals negative 5. Awesome. So when the problem says prove that there is a vertical asymptote, or prove, or is there a vertical asymptote, or something like that, you are using definition. And this over here is the procedure now that we are using to find the limit. So you will be solving the limit, and that will tell you whether the answer is positive or negative infinity. We will say whether it's vertical asymptote or not. Cool. Next is the positive 5. So limit x approaches positive 5 from either left or right, doesn't matter. X minus 5 over x squared minus 25. We know that it, again, cancels. And what do we get? Do I need to graph this one? Do I? We get 1 over 10. Very good. We can just solve by plugging in. Now, is 1 over 10 in infinity? No. By our definition for vertical asymptotes, is there a vertical asymptote at 5? No, right? It's infinity. It's not infinity. So since it's not infinity, no VA at x equals 5, because no infinity. There we go. And you sort that out in your notes any way you want. Now, this is actually very useful because you can see immediately how to graph the entire function. If this is your -5, and let's say here's your 5, this is how a function looks like. You have a vertical asymptote at -5 because our limit calculation gave us infinity there. And you just have an open circle at 5, 1/10. So the y value, the height of that open circle is 1/10 because that is what the value at 5 is. Now look, that point doesn't exist because you cannot plug in x equals 5 in the original problem. Remember, it's x squared minus 25 in the denominator. So neither 5 or -5 would work in calculations. And graph has to reflect that. So even though there is no vertical asymptote here, you still have open circle at least. And there is a vertical asymptote on the left. And that takes care of the problem. Now you might run into a problem that will have both of them because they both, none of them cancels actually. So, you can have all possible combinations. Now, are you going to learn this problem by problem, case by case? The answer is hell no. Because we can come up with all different types of functions. We know that ln function has the asymptote as well, right? ln has the vertical asymptote at 0, which you can shift if you go ln of x plus 3, ln x minus 3 or something like that. You can shift that around. So you are not supposed to learn example by example. You are supposed to learn that the definition for vertical asymptote is you are taking the limit as x goes to a value that you're suspicious of, that might have a vertical asymptote. And if that limit produces infinity, yes, there is a vertical asymptote. If it doesn't produce infinity, no, there is no vertical asymptote, just like in this example. Now, this was a cool example because it has both situations happening for the same function. And we had two different candidates, -5 and +5. Once we apply the definition for the limit, which you for vertical asymptotes, which you should memorize and learn, that's the one you learn. The outcome of that calculation will tell you whether there is asymptote or not. Guys, there is no way in hell that you can memorize every single example because there is this vast amount of functions out there. You're familiar with what? Polynomials, exponentials, logarithmic functions, trig functions, and hopefully you remember them, right? We have absolute value, well, no, vertical asymptote there. You have the square root, you have, right? So there is a book with 2,500 pages called Mathematical Functions, where polynomials take 1 page. Right? Right. So, technically, how many functions do you get to learn in entire pre-calc and calc career? You get to learn at best 5 or 6 pages from that book. Now, I told you that that book has 2,500 pages. And with pre-calc amount of functions you learn, you covered at best 6 pages, let's say. So that's how vast the mathematics field is in terms of functions. So do not try to learn this example by example and say, okay, in class he did 1/x, and now I know that has a vertical asymptote at 0. Check. And then, because you are learning here the definition for vertical asymptote, which says, I am suspicious of vertical asymptote at 0. I will compute the left limit at it, or the right, whatever you like better. And if I get infinity, yes, it is asymptote. If I don't get infinity, no, it's not. And you are done. That's where it ends. That's the proper way to do this class. Theorems, definitions, procedures, not memorizing individual examples. That gets you into trouble. because you can see it's different from example to example. The principle is the same, but the method might be a little bit different. And definitely the answer. Believe it or not, we're done with 2.4. You are learning this one concept of the vertical asymptote, computing the suspicious points, one-sided limit, either from the left or the right, you pick. If you get infinity, vertical asymptote is there. If you don't get infinity, it's not, and you are done. I will restart the stream, and we go into 2.5.